October 15, 1993, 2:34 p.m., Mayo Clinic Neurological Research Center, Rochester, Minnesota. Dr. Patricia Chen, the world's leading expert in musical cognition and brain mapping, stared at the MRI results displayed across 3 monitors with a mixture of fascination and disbelief. The brain scans belonged to 35-year-old Prince Rogers Nelson, who had volunteered for her groundbreaking study on how professional musicians process complex musical information. What Dr. Chen was seeing shouldn't have been possible, according to everything neuroscience understood about human brain capacity. Prince's neural activity while composing music showed simultaneous engagement of brain regions that were supposed to be mutually exclusive, processing speeds that exceeded known human limitations, and cognitive patterns that resembled what scientists theorized might exist in a brain that had evolved specifically for music rather than general human survival. The results were so extraordinary that Dr. Chen would spend the next 3 hours running additional tests, convinced her equipment was malfunctioning, until she realized she wasn't looking at a mistake. She was looking at evidence that some human brains operate according to principles that science hadn't discovered yet. If you believe that true genius might represent something beyond normal human evolution, and that some individuals possess capabilities that science hasn't learned to measure or explain, please subscribe to discover the moment when medical research encountered a mind that challenged everything we thought we knew about the limits of human cognition. Dr. Patricia Chen had established the Mayo Clinic's Musical Cognition Research Laboratory in 1991 with a specific mission to understand how professional musicians' brains differed from those of non-musicians, and whether intensive musical training created measurable changes in neural structure and function. At 41, Dr. Chen was internationally recognized for her pioneering work in cognitive neuroscience, having published over 200 papers on brain plasticity, musical processing, and the relationship between artistic ability and neurological development. The technology available to Dr. Chen in 1993 represented the cutting edge of neuroimaging, functional magnetic resonance imaging, fMRI machines that could observe brain activity in real time, measuring blood flow and oxygen consumption in different neural regions with unprecedented precision. This technology allowed researchers to watch how brains processed information, revealing which areas activated during specific cognitive tasks. Dr. Chen's current study focused on highly accomplished musicians, examining how their brains processed complex musical information compared to trained musicians and non-musicians. She had already scanned 47 professional musicians, including symphony orchestra members, jazz pianists, and classical composers, building a comprehensive database of musical brain patterns. Prince's participation in the study had come about through his friendship with Dr. Michael Rodriguez, a neurologist who had treated Prince for stress-related headaches in 1992. During their conversations, Dr. Rodriguez had been struck by Prince's descriptions of his creative process, particularly his ability to hear multiple complete arrangements simultaneously and to compose different musical parts for various instruments in his mind without needing to play them physically. Prince described hearing music in a way that didn't match anything I'd encountered in medical literature, Dr. Rodriguez later explained. He talked about perceiving rhythmic, harmonic, and melodic information as simultaneous but distinct streams of consciousness. Most musicians report thinking about one musical element at a time, but Prince seemed to be processing everything at once. Dr. Rodriguez had introduced Prince to Dr. Chen, suggesting that Prince's cognitive abilities might provide valuable insights for her musical cognition research. Prince agreed to participate, partly from scientific curiosity and partly because he was interested in understanding his own creative processes more completely. The initial consultation had taken place on October 10, 1993. Dr. Chen conducted extensive interviews about Prince's musical background, creative methods, and subjective experiences during composition and performance. Prince's responses had been unlike anything she had documented from other musicians. "When I'm writing a song," Prince had explained, "I don't hear one instrument and then add others. I hear the complete arrangement immediately. Drums, bass, guitars, keyboards, vocals, harmonies, all existing simultaneously in my mind. It's like having a full recording studio operating inside my head." Dr. Chen had been intrigued but skeptical. Most musicians, even highly accomplished ones, reported building musical ideas sequentially, adding instrumental parts one at a time. The ability to hear complete arrangements instantly suggested cognitive processing that exceeded known parameters for human musical cognition. "Can you demonstrate this?" Dr. Chen had asked during their initial meeting. Prince had hummed a melody while simultaneously beatboxing a drum pattern and tapping out a bass line on the table. But what struck Dr. Chen wasn't just his ability to produce multiple musical elements. It was his claim that he was hearing additional parts that he wasn't vocalizing. "There are 3 more guitar parts, keyboard harmonies, and backing vocals happening in my mind right now," Prince had said, while maintaining the melody, rhythm, and bass simultaneously. "What I'm performing for you is maybe 30% of what I'm actually hearing." If Prince's self-reports were accurate, his brain was processing musical information at levels that exceeded anything documented in scientific literature. Dr. Chen designed a testing protocol specifically to measure these claims objectively. The October 15th scanning session was designed to observe Prince's brain activity during various musical tasks, listening to simple melodies, composing single-instrument parts, and creating complex multi-instrumental arrangements. Dr. Chen hypothesized that Prince might show enhanced activity in known musical processing regions, but she expected his brain patterns to fall within previously documented ranges. Instead, what she observed redefined her understanding of what human musical cognition could accomplish. During the first test, listening to a simple melody, Prince's brain showed normal patterns consistent with other professional musicians. His auditory cortex, memory centers, and pattern recognition areas activated predictably. But when Prince began composing original material, something unprecedented happened. Multiple brain regions that typically activated sequentially began firing simultaneously. The left hemisphere areas responsible for rhythmic processing operated in perfect coordination with right hemisphere regions handling melodic and harmonic information. Most remarkably, Prince's brain showed simultaneous activity in regions that neuroscience had identified as mutually inhibitory, areas that shouldn't be able to function together at the same time. It was like watching someone use 100% of their brain for musical processing, Dr. Chen later wrote in her research notes. Every region we could identify as related to musical cognition was fully active simultaneously. According to everything we understood about neural resource allocation, this should have been impossible. Even more extraordinary was the speed at which Prince's brain processed musical information. Neural firing patterns showed information moving between brain regions at rates that exceeded the documented limits of human synaptic transmission. Prince appeared to be thinking about music faster than current science suggested human brains could think about anything. Before we reveal how Dr. Chen's additional tests confirmed that Prince's musical cognition operated according to principles that science hadn't discovered, let me ask you, have you ever encountered abilities in yourself or others that seem to exceed normal human limitations? Have you wondered whether some people might represent evolutionary developments we don't understand yet? Share your thoughts in the comments, because what happened during the extended testing session challenged fundamental assumptions about human cognitive capacity. Dr. Chen's initial response was to assume equipment malfunction. The patterns she was observing fell so far outside normal parameters that technological error seemed more likely than genuine superhuman cognitive ability. She spent 20 minutes running diagnostic tests on her MRI equipment, checking calibration settings, and reviewing software protocols. Everything tested normally. Convinced that she must be misinterpreting the data, Dr. Chen brought in 2 additional neurologists to observe Prince's brain activity independently. Dr. James Martinez, a specialist in cognitive processing speeds, and Dr. Sarah Williams, an expert in brain region interactions, both confirmed what Dr. Chen was seeing. This violates basic principles of neural resource allocation, Dr. Martinez observed. Human brains can't process information this quickly while maintaining this level of complexity. It's neurologically impossible. Dr. Williams was equally baffled. These brain regions shouldn't be able to function simultaneously at these activity levels. We're looking at neural patterns that don't match any documented human cognitive capability. But the most extraordinary results came during the final test. When Dr. Chen asked Prince to demonstrate his claimed ability to hear complete musical arrangements instantaneously, Prince closed his eyes and began creating an original composition while the MRI monitored his brain activity. What the scan revealed challenged every assumption about how human musical cognition functions. Prince's brain was simultaneously processing what appeared to be 7 distinct musical elements: melody, harmony, rhythm, bass line, percussion, and 2 different harmonic accompaniments. Each musical component activated different neural networks, but all networks operated at peak efficiency without interfering with each other. Most impossibly, Prince's brain showed predictive processing patterns, neural activity suggesting he was hearing musical elements before he had consciously created them. His brain seemed to be composing music faster than his conscious mind could follow, then presenting completed musical ideas to his awareness as finished products. It was like watching someone receive radio transmissions from a universe where music already existed in complete form. Dr. Chen wrote in her research journal, "Prince's brain wasn't creating music, it was discovering music that somehow already existed in his neural networks." The data from Prince's session was so extraordinary that Dr. Chen spent the next 6 months attempting to replicate her findings with other musicians. She tested virtuoso performers, renowned composers, and musical savants, hoping to find similar patterns that would help explain what she had observed. No other test subject came close to Prince's neural performance metrics. Classical composers showed enhanced activity in creative regions, but processed musical elements sequentially. Jazz improvisation specialists demonstrated remarkable pattern recognition abilities, but within normal cognitive speed ranges. Even musical savants, despite extraordinary specific abilities, showed brain patterns that fell within documented human parameters. Prince's neurological profile remained completely unique. Dr. Chen's findings were so unprecedented that she was initially unable to publish them in peer-reviewed journals. The results were simply too extraordinary for the scientific community to accept without extensive verification and additional research. "I was asking the scientific community to accept that human musical cognition could operate at levels we had never documented," Dr. Chen later explained. "The claim seemed impossible even to me, and I had observed the data directly." Finally, in 1995, Dr. Chen published her initial findings in the Journal of Cognitive Neuroscience, but only after recruiting 12 additional researchers to verify her methodology and independently confirm her results. The paper, titled "Extraordinary Musical Cognition: A Case Study in Neurological Exceptionalism," became one of the most cited research studies in musical neuroscience history. Dr. Chen's research on Prince sparked an entirely new field of study. Exceptional cognition research focused on individuals who demonstrated abilities that exceeded normal human parameters. Universities around the world began seeking subjects who might possess similar extraordinary cognitive capabilities. But no subsequent research subject matched Prince's neurological profile. Over the following years, Dr. Chen maintained contact with Prince, conducting annual brain scans to monitor whether his extraordinary cognitive abilities changed over time. The patterns remained consistent and, if anything, became more pronounced as Prince aged. Prince's brain seemed to be optimizing for musical processing in ways we couldn't explain, Dr. Chen noted in her 2000 follow-up study. Instead of cognitive decline with age, he showed continuous enhancement of already impossible musical processing capabilities. The research had practical implications for understanding human potential. If Prince's brain could process musical information at superhuman levels, perhaps other individuals possessed similar extraordinary abilities in different cognitive domains. Dr. Chen's work inspired research programs investigating exceptional mathematical cognition, spatial processing capabilities, and memory formation in individuals who demonstrated abilities beyond normal human ranges. When Prince died in 2016, Dr. Chen was invited to speak at a medical conference about her research findings and their broader implications for neuroscience. Prince's brain taught us that human cognitive potential might be far greater than we previously understood. Dr. Chen explained to her medical colleagues. His neurological capabilities suggest that some individuals might represent evolutionary developments in human consciousness that we haven't learned to measure or understand. The Mayo Clinic preserved Prince's brain scan data as part of their permanent research archive, making it available to neuroscientists worldwide who continue studying exceptional human cognition. In 2020, advances in brain imaging technology allowed researchers to analyze Prince's 1993 scan data with unprecedented detail, confirming Dr. Chen's original findings and revealing additional patterns that 1990s technology couldn't detect. Current research suggests that Prince's brain showed characteristics consistent with evolutionary adaptations, specifically for musical processing, neural structures and connections that appeared optimized for complex auditory information processing in ways that exceeded normal human development. Prince may have represented a glimpse into human cognitive evolution, current Mayo Clinic research director Dr. Michael Thompson explains. His brain showed adaptations that we're only beginning to understand, suggesting that human potential might include capabilities we haven't discovered yet. Music schools now teach Dr. Chen's research as part of curricula on creativity and cognitive science, helping students understand that artistic genius might involve neurological capabilities that science is still learning to measure. The research has also influenced therapeutic approaches for individuals with neurological differences, suggesting that what medicine sometimes categorizes as disorders might actually represent alternative forms of cognitive organization that could be enhanced rather than treated. Prince Rogers Nelson's brain scans revealed that what we call impossible might simply mean not yet understood. His neurological capabilities challenged scientific assumptions about human cognitive limits and opened new territories for research into exceptional human potential. A routine research study became a scientific revolution, proving that some individuals operate according to principles that science hasn't discovered yet, and that true genius might represent evolutionary possibilities we're only beginning to recognize. If this story reminds you that human potential might exceed everything we currently understand about our own capabilities, and that some people might represent glimpses of what human consciousness could become, please subscribe to keep these discoveries alive. Because the world needs more research into exceptional human potential and recognition that impossible might just mean undiscovered.